Good morning, everybody. I'm just getting everything ready and then we will begin. So slow. It's loading. I can see it loading. Oh, there we go. Wow, it's really slow. Okay, perfect. Now, we talked about the different calculations involving percentages. I really don't have that much today. It was just too much for a single session. We now want to simply put a word problem layer on top of the percentage calculation. So the challenge is to figure out, well, first understand the question, of course, and then to figure out which of the three or a combination of them am I going to use to figure out the answer. All right. So we have exercise 15.4. In a store, there is a coat that was originally $120. During a sale, it costs only $90. What is the percentage discount? Okay, so let's see here. Exercise 15.4. Of course, there are many more in the problem section as well. These are just a few examples of word problems. So my original price, I like to list what are the things that they give me is $120, my original price. They give me the new price or the new amount that is $90. So it's not always going to be the same. They don't give me a percentage and then ask me to decrease the 120 by that percentage. They give me the answer. Now there are multiple ways to go about this. I'm always looking for the simplest one, and it is a guessing game for me to try and guess what would your thinking be, what would fit the best for you. It's hard for me to say, right? So you have many options here. Let's suppose some people like to focus on the change amount. Let's say the decrease amount. So I'm reminding myself, oh, it's a decrease. What's the amount only? Is of course $30. And then we can focus on the percentage change, or the decrease in this case, is then 30 as a percentage of the original. And then of course I multiply that by 100 and I get my percentage value. Let's see what that is. 30 divided by 120. It's nice to see it for everyone to see. MathBot says 25. So it's let's leave the sentence for both. It's just going to be the same concluding sentence, right? Okay, so the one on the one hand, I can do it this way, and there's nothing wrong with that. Sometimes it feels a little bit more intuitive to me to focus on the change amount because I want to know what is the percentage discount, the percentage change, the percentage decrease, or whatever you want to call it. Or you can also just take the, let's say here, new as a percentage of old. It's always relative, new relative to old. Then that would be 90 relative to 120 over 120, and we make that a percentage. Let's see what we get. Let's see, 90 divided by 120 times 100. It's nice to see. Whoopsie, random line. Nice to see that 75. The difference is now I have to interpret this 75 because this isn't exactly what they're asking for. It's one option I can take to get towards the answer, but it's not the answer they're looking for. They want to know what is the percentage change, what is the discount percentage, how many percent off the original price. So I just have that the original price is 75% of the original. So that means it is going down from 100. So let's say here, down by 25%. Oopsie. From the original 100% amount. I'm just writing these things out because there are people that they don't really have a sense for this yet. They don't have a lot of experience. They haven't done anything. They haven't thought about it. We need to build that experience. But if this is too much for you, then I apologize. I don't really care. I need everyone to be aware of the detail and the options and all kinds of things. So it's very much an or. But in both cases, we'll say a concluding sentence. The new price is a 25% discount. Using their words, it's a decrease of 25%, whatever you want to, however you want to phrase it. So it's good to know my options. How do I feel more comfortable going about this? But of course, the end result is the same. All right. So that is one example. And it's all a matter of what information are they giving me. Maybe I could say here what is being asked. The, let's say here, decrease percentage. Oops, that's a big zero. Asked. Or let's just say question mark. Question mark. So it's good to know what are they giving me, what are they looking for, and now I have to figure out how to get there. Okay. Let's see exercise 15.5. And again, I'm happy if these things are super easy for you based on your experience and your background, but that's not the case for everyone, which is why we're doing it. In another store, a coat is reduced by $20 to a sale price of $100. What's the percentage discount now? And I've seen people taking these things for granted, going too fast, and then just using the wrong numbers in the wrong place. When they thought they understood, but they didn't really make sure to think about these things. So now I'll say change amount is $20. That's a decrease. Let's write here, decrease. And my new amount, new price, whatever you want to call it, is $100. They want to know, again, what is the decrease percentage or the discount percentage. Okay. But the information that I'm given is different. So now I can go again and look at the two to know my options, but you don't have to do both, of course. just in the same spirit as the previous one, I focus on the decrease amount. However, it's when I look at the percentage, it's relative to the original. It's relative to the original. So I am going to have to find what is the original amount. And of course, it is 120 because I went down to 100. So just to keep it similar to this, the percentage change is then the change amount relative to the original, and I make that a percentage. Now let's just go to MathBot now, why not? Let's see what we get here, 20 over 120 times 100. It is 16.67, let's round it, 16.67. Now you can put the percentage sign there if you want to. Or my other option was to look at new relative to old. I still need to know the original amount. And then I can say new as a percentage of old is 100 over 120. And I make that a percentage, of course, by multiplying by 100. Or not make it a percentage, I get the percentage value. Let's see, 100 divided by 120 times 100. And we get 83.33 if we round it. Now again, this is the answer. If I take the right root, then I get the new percentage, not the percentage decrease. So I have to go down, and let's maybe say here, note from 100% down to 83.33 is going to be my 16.67. So in both cases, the answer is of course the same. How did we phrase it here? New price. Okay, so let's say here, the new price is 16.67% discount. It's okay to round my presentation numbers. I'm not using this in the future calculation, so I don't need to worry about rounding, excuse me, creating errors. All right, so I mean the same style question. I just have to be aware of what information is given, what are they looking for, and then make a plan. How am I going to get there? It's not about getting the shortest one, it's going the route that feels the best for you. It's the same as any other problem solving issue. Understand the question, the information that's being given, what is being asked, and then make a plan. And it's nice that there are multiple options. Slightly different, but essentially the same thing. All right, we have our next exercise. Exercise 15.6, which is perhaps a little different, but it's just there. These exercises are there to just make us aware of certain things that if we don't think about them beforehand, we can easily make a mistake by putting the wrong numbers in the wrong place. Let's see here, 15.6. In a certain area, City A's population is 15,000 and City B's population is 12,000. Now calculate some things. What is City A's population? Sorry, City A's population is what percentage of B? A is what percentage of B? Let's just write down what they are originally because I'm going to move this PDF over side to side all the time. So city A has 15,000 people, and city B has 12,000 people. I'll just write it down. We have the time. Trying to stretch this out. Why not? So city A is what percentage of B? So now there isn't a new and an original. They have to sort of tell me which one do I want relative to which one. A is what percentage of B. So A relative to B. So here's my answer. A relative to B is 15,000 over 12,000, and I make it a percentage value, or I casually say make it a percentage. That's not really true. I just get the percentage value by multiplying by 100, of course. 15,000 divided by 12,000 times 100. Hopefully I type my zeros right. And we get 125. I'll just write here percent. Now it's good to think, well, does that make sense? Yes, because city A has more people. It's bigger than B. What percentage is it? 125%. So it should be over 100 because it is more than the number I'm comparing it to, the 12,000. Then the second one is just flipped around. B is what percentage of A? So now very similar. It's just a question of what goes where. Which one relative to which one? B is relative to A. So it's like B is new and A is original. So it's 12,000 compared to 15,000. Get the percentage value, see what we get. 12,000 divided by 15,000, make it a percentage. Ooh, random line. 80%. That makes sense because B is smaller. What portion of A is B's population? 80%. So it's not something I want to take for granted. Knowing what goes where and understanding the sentence, understanding the question, and what I'm comparing to what changes things significantly. So it's something I need to think about beforehand. All right, so now let's just show the next two are similar but different from the first. City A is what percentage larger than B? A is what percentage larger than B? Let's write that down. A is what percentage larger than B? So now I have to think for myself, how am I going to go about this? I have two options, just like there. Now, this isn't true for every single thing we're going to do in the future, but often I have multiple ways to go about it. And one isn't necessarily more efficient than the other. I can focus on the change amount, or, not and, I don't have to do both, or I can look at one as a percentage of the other and then deduce from that the change percentage change rather. Again, here I have the same thing. I can look at the change amount. A is what percentage larger than B. A is 3,000 people larger. So I can focus on the amount, the increase amount. To get A, I have to increase by 3,000 increase amount. So then the percentage increase, if you will, is 3,000 compared to which one? Compared to B. And I get the percentage value by multiplying over 100, and let's see what we get. 3,000 divided by 12,000 times 100. We get 25. Of course, that'll be 25%. Or I can look and say, what is the percentage new to old, so to speak, A to B? But we've already done that. Now, normally you might not have had that in a previous question, but we have it right here. So let's just write it down. A is 125% of B. Not 125% larger. It's just when I compare the two amounts, A is of course the bigger one, right? So then from this, I also get an increase or increased by 25%. Lots of ways you can phrase it, doesn't really matter. So in both cases, I get the 25. Sometimes I have the luxury of choosing which way I want to go, focus on the change amount, and then make that a percentage, or focus on the percentage and then get the percentage change from that, because it's all relative, an adjustment from the base 100. Sometimes, honestly, I don't have a choice, and the more questions we'll do, the more we'll see the variations that you might encounter. For now, it does seem like we have a choice every single time. When things get a little more complicated, the two choices aren't quite as equally efficient. Now in number 4, we're just going to flip that around and ask B is what percentage smaller than A? With these basic questions, we build on that foundation. So we really have to make sure we can do these basics, interpreting the words, but the calculations are still quite straightforward. So now again, I have a choice. I can look at how much smaller is it. Let's use different words. How much smaller? What is the change amount? Well, it's 3,000 smaller, right? The numbers are the same. But in this case, we're looking for the percentage change, 3,000, relative to A. So over 15,000. It's all relative, right? It's all a fraction. It's compared to something. Let's see what we get here, just to see something. It's not super complicated. 3,000 divided by 15,000 times 100. And we get what you might expect, the 20%. So if I focus on the change amount, make that a percentage, of course, I have to take care what goes where. Then I get my answer. Or I could notice, well, I've done some work already here, in that I've seen what percentage is B of A. It's 80%. Let's just write that down. B is 80% of A. So from that, I can also get that it's did I say decrease? Did I say decrease up here? No, it's all good. It's a decrease of or by or whatever, 20%. Because it's from the base 100 I went down by 20%, so it's a 20% change. So in either way, in either case, I get the same result, of course. So in these basic situations, know your options, which one you prefer. Maybe you don't care which one. Maybe you do care. It's important to think about it first. To think about it first. All right. So those are definitely the basics. Now, the benefit of percentages and having a standardized fraction, uh, because the numerator, sorry, the denominator is always 100, definitely has approximation benefits that I can look at percentages that come up a lot that are easy to calculate in my head and use that to get close to specific answers. When I just want to get a sense for what the answer is, it doesn't have to be perfect. So when I have to calculate or estimate 35% of a number of people, 52% of a certain amount, 65%, 15%, 23%. I mean, these percentages are all over the place if you just start looking for them. And I often, maybe I'm comparing two items in the store, they both have a discount, but it's not quite clear which one is better. If I can just quickly have a feel for or a sense of these percentages, a number sense for percentages. I don't have to say, oh, well, hold on, take out my phone. Well, how did the calculation go again? I kind of remember. No, I just have a sense for what fractions these percentages are close to. So let's just sort of highlight that. We'll just talk through it, but I'll do it over here. Um, let's say here, easy percentages. Sometimes I can get very close, sometimes I can't. Definitely 10% is an easy one, just a tenth, so dividing by 10. 20% would be a fifth. Now there are many more. 33.3% would be a third. Of course, we have 50%, which is a half. And then we go to fractions a little larger. Maybe 66.6 repeating would be 2/3, 75%, 3/4, and so on. You can add more to this, but it really depends. I don't want to make them too much. I want the fraction to be a very easy calculation, right? So we can use these and we'll just talk through them briefly. So if I look at the first one, let me zoom in a little bit. If I have a 35% of 120 people, I could say, okay, well, that's very close to 33.3%, which is going to be a third. So my answer is going to be a little bit more than a third. So all I have to do is divide this by 3, and that division doesn't have to be perfect either. I get around 40. So it's very often, an answer of, oh, it's a little more than 40 is more than sufficient for immediate practical purposes. But I need to know, how do I get approximately 40 in my head? Just going to a percentage that would give me a very quick and easy calculation. 52, obviously very close to 50%, so the answer is going to be very close to half of this, which is very easy to do. So it's a little over 6 pounds. So feel free, if you're watching the video or later on, to pause and see what would you do. Can you estimate these? How close are you? Sometimes you get pretty close. If my percentage is close to one of these easy ones, sometimes it's a little bit unfortunate. 65 is very close to the 2/3 percentage, right? Now 2/3 uh, might not be as easy as dividing by 2, but I see that my 67 kilometers is also very close. And the calculation might be easier than you think, in that I can break this up into 3 pieces, roughly 22 and then 2/3 of that would be around 44. I'm a little under, it's hard to say because I sort of approximated both of these numbers, but it still gets me in the right range of number. If I look at 15, 15 happens a lot. I didn't write down 15. 15, I'll write down over here, is nice. Now, for the longest time, I didn't really think about this like I should have, perhaps. And I thought, ooh, this is close to a sixth, which is a little bit low, but it would work. Dividing by 6, I can do that. I want a numerator of 1, right, ideally. But if I think about this as 10%, now I'm casually writing these things. I wouldn't normally write a percentage in a calculation. Uh, I'll just informally do the plus here. I can do 10% very easily, and 5% is a half of that. A half of the 10% that I just got. So if I just add that little extra, then I would get 15%. And working with 10% is probably the easiest one I can do. So if I have 15% of this number, of course I don't have to look at this specific number. I can look at it as 40, which is going to be much faster in my head. I know I'm making a little bit of an error, but it's not very big. So I go to 10% of 40 first, so that'd be 4, super easy. And then another half of that, so another 2. So 15% of this is approximately 6. So 15% is nice to do. And it's sometimes, like for me it was way back, that I didn't do this until someone said, just take 10% and then add another half on top of that. Like, oh, and sometimes that's how it works. Something clicks when someone else says it. And then you're like, how did I not think about this? 23%, did we do it 25 here? No, we did not. 25% is another easy one, which is 1/4. And whenever I have a numerator of 1, that's going to be quite convenient. So 25% of 102, or I can just take 25% of 100, so 1/4 of 100, and then I get 25. I know I'm not quite perfect, but very often it's close enough. 35%, I can go back to the number 1 here, like a third, it's very close. 76%, and I can go to 75%, which is 3/4. And because my number is very close to 400, that makes it easier as well. Then I can get other kinds of questions where the things are just flipped around. What percentage, approximately, of 400-ish is 66? Now I can decide 66 is a little, I can be very aggressive in my rounding and go to 50, but then of course I know the further away I go, I get convenience, but I lose accuracy. Or if I'm more comfortable with mental arithmetic, I can try a 65, I can try a 60, but 50 and 400 would be the easiest calculation. So you can practice going the other way as well, and then do it with your calculator and see how close was I. And the nice thing I used to tell kids with estimation question is, technically, you can't be wrong. Anything you say here is right because it doesn't say what accuracy I need to have. If I want to estimate very aggressively, there's no indication that that is wrong. It's estimation is a vague term. It can be anything. So really, in a way, without more specifically stating here in the question how accurate your estimation should be, technically anything is correct, which is kind of nice, takes the pressure off. But of course, in practical situations, you want to be fairly close in your answer. But what does close mean? It depends what I'm going to use with that answer for. Next one here, 74 miles. That's pretty close to 75. What percentage of? Well, I can use a 300 here. And I know my adjustments weren't big, so my answer is going to be fairly close. How close? I don't know until I calculate it precisely. But if you do budget questions or you just think about, okay, how much money should I take with me on a trip? You just want to be in the right area. It doesn't have to be precise. It depends on the needs. Or if you want to, if you're looking at miles, for example, and you want to make sure you have enough, uh, you want to estimate and then just add a little bit more to make sure that you have enough. It depends on the situation. 24 pounds is 49% of what? Here I can take 50% very easily, and then it's just a little bit in reverse. So the 50% is a half, so I could say, well, 24 is a half of what? So I just have to reverse that by doubling it. So it's very handy, and it gives you confidence as well out there to have a sense of percentages. So often, just in casual conversation, someone asks me, or it comes up, some percentage of something. What would that be? No one that I know would want to say, well, stop the conversation. Let me take out my phone, open my calculator app, and calculate this. No one does that. No one cares. No one wants to. It just doesn't work like that in a conversation. You want the conversation to flow. You just want to get a sense of the number. You need an understanding of percentages, but it's all estimation, really, in conversation. But I've never had a situation where someone would say, whoa, whoa, let me just get out a calculator. Unless it's something that we want to know precisely, of course. That's a different situation. Casual conversation, no one wants to do that. So the argument that kids have that, oh, why do I need to do anything in my head? Because I would have my phone with me. I could just calculate it. Technically, yes. And when it's an important answer that you need to rely on, sure, be precise, absolutely. But in conversation, that's just not how it happens. If you have to pause and take out a calculator, it's just not how it works. No one wants to do that. No one does that. And then it comes to down to you either have a sense of these things or you don't. And having some sense fills me with confidence that I might not have convenient numbers that I can round, sure, but very often I do. And just the ability to be able to work with them, it's really a confidence thing that I feel empowered out there in the real world. All right. We are finished a little early today. I'll hang around if you have questions. You can try some of the problems, but it's important that you think about them. Take your time. We aren't done with our percentage discussion, but we'll leave the next bit for next time because it crosses over into the next chapter very nicely. It's really a part of the next chapter, but still on percentages. So have a look at the problems here. Take your time with them. There are, of course, many. These are just some, but it gives you an idea of percentages and how to work with them. All right. Are there any questions at this stage? All right. Then that will be the end for today. Enjoy the rest of the day, I guess. Until later.